SSH. In this nugget, we're going to look at the SSH program, which allows you to connect securely to other machines on the internet. We'll talk about how to set up an SSH server, and we'll also go through how to use an SSH client. Along the way, we'll talk a little bit about public key cryptography so that you understand what's going on behind the scenes of SSH. So pull up a chair and let's get to work. Let's start out this nugget by talking about SSH, which stands for Secure Shell. When I first started using Unix and Linux, the way that you would connect to a computer remotely is you would use commands like RSH, which stands for Remote Shell. So I could say RSH, type in some domain name, and then it would prompt me for my username and my password on that remote machine. Okay? Another way that you would connect to other machines is via the telnet command. Well, all those commands are weak because they transmit all the data across the network in a plain text fashion. So it lets somebody, that has a packet sniffer or some sort of network probing device look at the network and see all the information that's traveling across in plain text, and then they can steal it, like your username, your password, the data that is sent, and so on. Now, Secure Shell is different. Secure Shell, the client will transmit, right from the very beginning, it'll transmit authentication info in encrypted form. So things like your username and your password are travel over the network in an encrypted fashion. So even if someone is packet sniffing, all that they're getting are encrypted packets, and they have to be able to decrypt those to get your username and your password. And we're banking on the fact that people can't decrypt this stuff easily. Okay? In addition to the authentication info being transmitted in encrypted fashion, the data that is sent back and forth between the client and the server is also encrypted. So, with Telnet and stuff, when I logged onto that computer, not only was my username and my password traveling across the network in plain text, but if I did some ls on some directory, or I catted out some file, or I read some email or something like that, all of that was also traveling over the network in an unencrypted fashion, in plain text format. Okay, so all of this being encrypted adds an extra level of security to the system. Other things that SSH can do is after a client first connects to a particular server, it can verify that it's connected to the same server on later sessions. All right, and another thing that you can do with SSH is that the client can use X11 applications launched from the shell. So not only do we get, our text-based Unix interface here, or Linux interface, we also get the ability to run graphical applications, and all that stuff will be encrypted as well. Now, what do you need to run SSH? Well, on the Linux side of things, there's an open SSH package, and the open SSH package contains a client, a server, and some other various helper packages. In order to run the SSH package on your Linux system, you also have to have an open SSL package, which stands for Secure Socket Layer. So this is a helper package for the base SSH packages. From other operating systems like Windows and Macintosh, there are programs that you can use to connect to Linux systems securely. I use PuTTY from Windows machines to connect to Linux machines. So all you have to do here is type in, the domain, then it's going to prompt you for the username and the password, and again, all that stuff is traveling over the network in encrypted form. And from Macintosh, you can use Nifty Telnet SSH. That's the Mac software. So just to review, why do you want to use SSH? You want to use SSH because it prevents interception of communication between two systems, so that people can't packet sniff out there and steal all your information like your username and your password. It also prevents impersonation of the host, though. So remember, we were saying that once you log on as a client, once you log on to some particular server, if you go to log on to that server next week, you'll be able to tell whether that's the same server that you logged on to last week. And one of the things that people do to steal your data, obviously they can sniff packets, but the other thing that they can do that's malicious is they can put a computer out there to impersonate the server. So you log on to what you think is the server, and it's really this other computer that's intercepting the data, and it's going to respond back to you just like it's the server, just to get your information, your username and your password and so on. Then it can turn around and actually log on to the server with that information that you gave to the impersonating server and gain access to all of your files. So these are the two reasons why you want to use SSH. Let's just take a step back and do a quick little overview of what public key cryptography is, and this will help you understand what's going on with the secure shell process. So in a public key cryptosystem, everyone has what's called a public key and a private key. And you can tell by the names, the public key is public. Everybody in the world can see my public key, and nobody can see my private key. The whole security of this system relies on me keeping this one key private. Okay. Now, the essence of this is that if I want to send a message to somebody, if I encrypt that with Joe's private key, all right, that message can only be decrypted with Joe's public key. All right, so if Joe sends a message and he basically locks that message with his private key, that message can only be unlocked with Joe's public key. All right, now I say only here and I draw a couple underlines under it. I mean, I'm saying only, but really we don't know of any way to unlock it except by using Joe's public key. If you discovered a way to unlock it without using Joe's public key, you'd either be really famous and on the front page of the New York Times, or you would be shut up and hired by the NSA and paid all sorts of money, or maybe you'd be dead or something. I don't know. But we're relying on this fact being true, and it's been, the really smart people have tried to break these codes with really powerful computers, and they haven't been able to. So that's our only proof that this whole system works, is the fact that we haven't been able to break it yet. Okay, so the vice versa of this statement is true as well. A message locked with Joe's public key can only be unlocked or decrypted with Joe's private key. All right, so let's do a little example here, and hopefully that'll make everything make sense. So in our example here, we have two users. We have Alice and we have Bob. Now these users could be using email to exchange private messages, or one could be a secure shell client and one could be a secure shell server. It doesn't matter. This example applies to any system that uses public key cryptography. All right, so say that Alice wants to send a message to Bob. So she writes out the message in plain text, and then what she can do is she can use Bob's public key to lock the message or encrypt the message. All right, so that's her first step. So she uses Bob's public key to encrypt the message. She sends the message over to Bob, and then Bob gets this message, and then he uses his private key to unlock the message or decrypt the message. And then he can read the message. All right, and that's it. So anybody who's reading over the network while this message is traveling over the network is just seeing gobbledygook, right? Because they can't read this because they don't have Bob's private key. Now, what if, Alice is a customer at a bank and Bob's, the head of the bank or something, and say this message says, "Hi Bob, this is Alice. Take all the money out of my account and put it in Joe Schmo's account," signed Alice. All right. Well, Bob's the only one that can read this message, but he really has no proof that it came from Alice, right? Because anybody could have taken it. Joe Schmo could have written this letter, encrypted it with Bob's public key, sent it to Bob, and then he could unlock it with his private key. Anybody can send a message and say, "Hi Bob, put all my money in Joe Schmo's account, signed Alice," right? And anybody could have done that. But the other thing that public key cryptography gives us the ability to do is authenticate who actually sent the message. So when Alice sends this message, if she really wants Bob to know it's from her and not from anybody else, then right after she encrypts it or locks it with his public key, she'll lock it again with her private key. So the second step to this process is lock the message a second time with her private key. Now she'll send the message over the network. Anybody reading this message still can't read the message because they don't have Bob's private key. This message was locked twice. It was locked with his public key and her private key. So how do we unlock this message? Well, Bob can unlock the message with her public key and his private key. If it unlocks and everything comes out good inside the message, then he knows that Alice sent the message. How does he know she sent the message? He knows she sent the message because her public key worked to unlock it. And the only way that it could have been locked so that her public key opens it is it must have been locked with her private key. It's also locked with his public key, so only he can read it with his private key. So see how this is working? It's like a four-step process. First, she does this with his public key, locks it with her private key, he unlocks it with her public key, and then unlocks it with his private key. And now he's got a message that only he can read, and he can prove it came from Alice. So there's authentication and there's secrecy in this whole process. Well, now that we understand the basics of SSH, now let's take a look at some specifics. We'll look at the configuration files and talk about the various settings that you can make in those config files. So there's a directory here called /etc/ssh, and in this directory are a bunch of configuration files, and you can see some keys and things like that. Now, sshconfig is the default configuration file for the client on this machine, Nugget SUSE, and sshd-config is the configuration file for the server on this particular machine. All right, so those are sort of the default configuration files for client and server. The way that I've set it up on this network is that Nugget SUSE here will be the SSH server, and then Nugget SUSE 2 will go over there, and that'll be the SSH client, and we'll use that machine to log into Nugget SUSE in a secure fashion. Okay, so let's take a look at the man page for the sshd config file, and that will tell you all the different things that you can set up in this configuration file. Well, this is a typical configuration file in that we use the hash mark for comments, so any line that starts with that will be ignored by the SSH service, and then there's a bunch of variables, and we set those variables one per line. So let's just look through this man page and talk about some of the most important variables that get set here. So except n specifies which environment variables you're allowing the client to copy over onto the server. By default, you don't let any environment variables get copied over, but if you wish to allow certain ones to get copied over, you can set that here. Then there's also allow groups and allow users. These two specify the groups and the users by name that you're going to allow to SSH into your server. And you'll see later on that there's also a deny groups and a deny users so that we can deny access to our server based on group or user ownership. Okay, so by default, all groups and all users are allowed to access our machines. As we go down further, you'll see there's this client alive interval and client alive count max. Client alive interval is a timeout interval, and so if, say it's set to 15. Then every 15 seconds the server is going to ask the client and say, are you still alive? If the client doesn't respond, the server won't terminate the session right away. They'll try some number of times specified by client alive count max. So client alive count max, say that's set to 3, then the server will try 3 times, and if there's no response from the client after 3 tries, then the session will be terminated. So this doesn't mean you have to be, typing commands on the client side. All this means is that the client program and the server program have to, do a handshake over a secure channel. All right, and if that happens, then your session will be allowed to stay active. If that doesn't happen after 3 tries, then your session will be terminated. And here's our deny groups and our deny users flag. This is where you can deny groups based on group name or users and from accessing your system via SSH. Then going down further, there's the host key. So this specifies where the private key for the host is kept. And we already saw up in the SSH directory that there were some keys up there. There were public keys and private keys up there. And there's actually 2 different protocols for SSH. Version 1 and version 2. For version 1, you use SSH host key, and for version 2, you can use SSH host RSA key or SSH host DSA key. Now, when we were talking on the whiteboard about public key cryptosystems, we just talked about public keys and private keys. We didn't specify any of the underlying algorithms. That's kind of beyond the scope of this particular video. But the difference between these keys is that one of them uses one particular kind of algorithm and another one uses a different kind of algorithm for actually doing the cryptography part of it, for locking that message and unlocking that message and so on. And that's why there's different keys and different protocol versions and so on. But the essence of it is that it's all public key cryptography, and it works basically like we were saying out on the whiteboard at a high level. Then another one down here that's important is, you can specify logging information. So you can specify what information gets logged to the log files and so on. Another one is maximum authorization tries. So here you're specifying how many times someone can try to log in via SSH and fail. If they fail this number of tries, then you're just going to block them out. And once they reach half this number, then you're going to start logging that information to keep track of it. So if somebody types their password incorrectly once or twice, it's no big deal. The default value here is 6. So once they hit 3, then you're going to start logging, and all additional failures are going to be logged as well. Okay, so there's also information about permitting a root login. So the default value here is yes, but you can specify for your system if you want to disallow root logins. All right. You can also specify for root logins without password. So if you're in a really secure system, you're not even connected up to the outside world or something, I don't know, and if you're just very, very certain of the security of your system, you can permit root logins without passwords. And that's very convenient for the system administrators, because if they're moving around from one machine to another, setting up various things, then it's nice if they didn't have to type their password at every single step of the way. Okay, so that's the kind of stuff that can be set in the SSHD config file. Now let's take a look at the variables and the parameters that you can set for SSH on the client side. Now we saw that there was that file up in the etc SSH directory called sshconfig, and that's kind of the system-wide config file. But actually SSH obtains information from 2 other places before it looks at that system-wide config file. The most important, sort of highest priority place that it obtains information from is from the command line. So if some parameter is set on the command line when SSH is activated, then that will override any of the settings in the system-wide config file or in the user's config file in their home directory. So in your home directory is a .ssh subdirectory, and a config file in there is kind of the second order of priority. So if something's not set on the command line, then the user's config file is the next place that's looked, and then the system-wide config file is the last place that's looked. Now we don't need to go through and look at all these parameters. They're very complementary to the ones that were set on the server side. So we had on the server side, like how much time can the client be, unreachable before we terminate a session, and we have the similar parameters in here. How much time can the server be inactive or unreachable before we terminate the session, and so on. And you have to remember that SSH is like a two-way street, that you don't want someone to pretend that they're a client, because then the server is going to pass that person information that they shouldn't have. And you also don't want someone to be able to pretend that they're a server, because then the client's going to give that false server information that the server shouldn't have, and then that false server can turn around and log into the real server and get that information off of the real server. So you have to be careful there both ways. That's why there's settings on the client side and the server side for these protections. So here we are sitting on the Nugget SUSE 2 machine, and we're going to use SSH to log into Nugget SUSE. Okay. Now, if I want to log in as the user Perry, this would do it. If I had a different username on Nugget SUSE from Nugget SUSE 2, I could specify that in front. So let me just log in there as the user Alice for demonstration purposes. So I'm going to hit enter here. And then it says the authenticity of Nugget SUSE can't be established. Here's the RSA key fingerprint. Do you want to continue? So what's going on here? Let me just continue and show you what happens first, and then we'll talk about what's going on. So I'll say yes. Now it says it's permanently added Nugget SUSE to the list of known hosts, and then it prompts me for a password. I hit enter, and now I'm logged on to Nugget SUSE as the user Alice. Okay? But what was going on back here? Why was it not able to validate the authenticity of Nugget SUSE? We were talking earlier about how SSH can verify that when you log into a particular system, it's the same system that you logged into in the past. All right? But the very first time that you go to log into a system, which is what we were doing up here, it doesn't know. It has no way of verifying that that system is who it says it is. So what it does is it gives you this fingerprint, and that fingerprint gives you a way to track down to make sure that that system is who it says it is. So this fingerprint is kind of like a sampling of the long RSA key. It's a short sampling. It looks kind of long, but compared to the RSA key, it's 1/100th of the length in terms of the number of characters. So what I could do is, if I really want to verify that this fingerprint came from Nugget SUSE, what I would do is I would call the system administrator of Nugget SUSE, or I would meet the system administrator of NuggetSUSE in a dark alley at 3 a.m. and talk to him about this, and we'd whisper, you know, and we would say, I would say, is your fingerprint of your key F2FE1C1000, and if he verifies that yes, that is the key, the fingerprint of my key, then I can be certain that this fingerprint matches NuggetSUSE, and this is the machine that I'm actually logging into. Okay, so that very first time depends on, you know, the kind of information that you're going to exchange, and also, you know, how uptight you are about these sorts of things as to, you know, what level of checking you're going to do. Typically what you would do here is you would just say yes, and then this fingerprint is saved in a file called known hosts in your .ssh directory, and then when you go back later to log into NuggetSUSE, you won't get this message anymore. It'll just compare the fingerprints. If they match, it'll just let you go through. However, if you go to log in the future and the fingerprints don't match, SSH won't let you log in. It'll say, wait, the security of NuggetSUSE has been compromised because it has a different key fingerprint. Now, another way that you can use SSH to get from NuggetSUSE 2 to NuggetSUSE is via the use of other keys, so that you don't have to type Alice's password when you SSH over to that machine. All right. So let's look at a program here called SSH KeyGen, and this will give you the ability to generate another set of RSA public and private keys to allow you to log on to that system in a sort of a different kind of secure manner. Okay, so here what we're going to do is we're going to say -t RSA. So this is going to generate an RSA style type of key, public and private key for the system. All right, so it's saying generating a public and private key, enter a file in which you want to save the key. I'm just going to use the default file there, and I'm not going to use a passphrase. We'll talk about that in a minute. Okay, so it says enter this passphrase again. Now it says your identification has been saved in ID RSA. Your public key has been saved in ID RSA.pub, and the key fingerprint is this. Okay, so you can tell somebody that key fingerprint if they are, again, suspecting that something is wrong with your key. Then the fingerprint is a way for you to tell that that's what's going on there. Okay, so now we've set it up so that in this directory we have ID_RSA and ID_RSA.pub. Now that my keys are generated, what I need to do is I need to get a copy of that public key over to the other account on the other machine. So I need to get it over to Alice's account on NuggetSUSE. So the way that I'm going to do that is to use the secure copy command. So here I'm going to say copy ID_RSA.pub, okay, and I'm going to copy it to Alice at NuggetSUSE, okay, and I'm going to specify, let me type that right, then you say : and then I'm going to give it the same name over there, ID_RSA.pub. Okay, so this will copy this file from our local machine over to NuggetSUSE in Alice's account in her home directory and call it the exact same thing. So SCP is kind of a relative to SSH. It's a copy. It'll let you copy files over the network, but it does so in a secure, encrypted fashion. So I do this, it says password, so I type the password in, and now it says, okay, it's 100% copied over there. Great. So now let's use SSH to log in over on NuggetSUSE again as Alice. And notice, oops, I typed it wrong there. Okay. Notice that it doesn't tell me that, you know, it can't be verified because now it's in the list of known hosts. So it just prompts me for the password and then it moves on. What it did do, though, that it didn't tell me is that it did verify that the fingerprint was the same as the last time that I logged on. All right, so now that we're over here, you can see that the RSA pub key is in my home directory now. And now what I'm going to do is I'm going to make a directory called .ssh. All right, so I'm going to create a .ssh directory on this machine. All right, I'm also going to set the protections on that directory so that nobody can look at it. So it's a change mode 700. All right, now what I'm going to do is go down into that directory, and I'm going to create a file there called authorized keys, and I'm going to append a 2 on it because we're using protocol 2. If you were using protocol 1, you would just create a file called authorized keys. All right, now I've created that file, and now what I'm going to do is change the permissions on that file to 600, okay, so that again nobody can read that file. So now we've set up our directory and file permissions on that particular file. Now what I'm going to do is copy that key from the home directory, ID RSA pub, into this authorized keys file. All right, so the way that I'm going to do that is I'm going to use the cat command. Now you might be tempted to, open that file up in an editor and then, highlight it or denote it and then paste it into a file called authorized keys 2. The danger with that is a lot of text editors will, when lines are really long, they'll cut them and put a new line character at the end of the line. So you don't want to do that. This public key is one line. All right, there's no new line characters in there. If you put new line characters in there, it would break. Okay, so the whole system would break down. So what we need to do is we need to cat that file, ID RSA pub, from the home directory and then append that to the authorized keys file here. And the cat command will not put in any line breaks. If it's one line before, it'll be one line after this command. Okay, so I do that, and now I've created the authorized keys 2 file here, and the permissions are all changed, and all the information from the public key that was in my home directory is now in this authorized keys file. Now what I'm going to do is exit out of here, and then we'll log in to Nugget SUSE using the fact that we've exchanged these keys now. All right, now let's use SSH to go back at Alice as at Nugget-SUSE. I'm going to hit enter, and notice it just logs me directly on. That's because I've done this key exchange, and I put in the authorized keys in Alice's directory the public key of Perry on Nugget SUSE 2, and so it just let the process go through directly without typing a password. That's just a different way to use SSH. Some people don't like this because they say, well, if somebody sits down at my computer, they can just SSH to wherever I have access to and gain access to those machines. So that's why there's the use of that passphrase that we didn't enter. So the passphrase is just an extra level of protection, so that not only would you have to type, SSH to the particular thing, you'd also have to enter the passphrase still to let you in. You might be saying, well, why wouldn't I just use a password on that machine? And that's a good question. That's just as secure. It's just a different way of doing things, and depending on the various systems, they can be set up differently. It's your personal choice how you set that up. Okay, well, it's time to wrap up our nugget on SSH. Remember that SSH provides secure connections over the network, whether it's a local area network in your office or the internet at large. It gives you a way to log on to another machine in a secure fashion so that all the information that gets transmitted over the network is encrypted, whether it's your username and your password or some email message that you're reading. Remember, the config files for SSH live in the /etc SSH directory, and there's config files in there for the server side and also for the client side. But remember that the client configurations can be overridden by configurations in the user's home directory in the .ssh subdirectory. And finally, we looked at using SSH with and without the use of additional keys. So that's just a matter of personal preference, how you want to set things up for your system, whether you want to use password authentication or whether you want to let people log in without the password and just have an additional key in the .ssh directory. Well, I hope you found this nugget informative, and thanks again for watching.